Okay, we've got a couple people trickling in, but we're going to go ahead and get started here. My name is Sean Maurer. I am a energy engineer at the Smart Energy Design Assistance Center. Joining me today is my colleague Ryan Siegel. We'll be going over air leakage and blower door testing, the code requirements, and some highlights about how the tests are performed so that you understand the process. A couple of housekeeping things as we go through our presentation. We will have some poll questions, so be prepared for those to pop up. A couple of things just to check that we've covered our content well, make sure that you understand some of the concepts. And also, if you have questions throughout the presentation, please enter them into the Q&A window. You should be able to find that by hovering over the top center or bottom center of your screen. If you do enter questions into the chat, we may not see them and catch them to answer during the presentation. So please do use that Q&A function. Let's go ahead and get started. So things we're going to cover today, just some basic understanding of the benefits of air leakage testing. Why is it important to do? Identifying the energy code requirements for air leakage testing, understanding the different testing metrics for air leakage in commercial buildings versus residential buildings, and identifying alternative compliance methods to pressure testing for commercial buildings. SEDAC is a preferred education provider through the IECC and works with AIA to provide continuing education credits. At the conclusion of this webinar, which is being recorded, you'll receive an email with a copy of the slides for the presentation and a link to enter your AIA member number, and we will follow up and submit those credits for you. So please do use that link so that we have your information to get you your continuing education credits. Here at SEDAC, we are an applied research program at the University of Illinois based in the Urbana-Champaign area, and our mission is to reduce the energy footprint of Illinois and beyond. And the Energy Codes training program is one of the many areas in which we work to achieve that. Again, questions are encouraged during the presentation. We want to make sure we're covering the content well and we're answering all the questions that you have. Again, please use that Q&A option to ask your questions to make sure that we receive them and answer them adequately. Our presentation today is sponsored by the Illinois Environmental Protection Agency's State Energy Office. We thank them for their assistance in funding this program and bringing this training to everyone. We also provide technical support at energycode@illinois.edu is our email address, and we have a 1-800 number as well. We do prefer that if you have a detailed question, you use that email address. Let us know whether it's a residential or a commercial project, as that will influence which section of the code that we're referred to. That gives us time to go through our office, review with each other, and get you the best answer. But if you do need just a quick answer to a question, that 1-800 number is available. We also have a number of online resources available at our website, smartenergy.illinois.edu/energy-code. Those resources include recordings of our previous workshops and webinars, access to online training courses through our Thinkific modules. Those training courses are kind of a entry-level themed courses. So for people that are new to the code, homeowners, business owners, people that you're trying to educate might find those useful to find some details. We also have our technical support line information linked there as well. And then we also have a number of available resources, including links to the IECC, the Illinois Conservation Code amendments, and the Chicago Energy Code, as well as frequently asked questions, smart tips that we have developed over time. We're developing links about Illinois stretch codes, which will be coming in the future. And again, probably the key thing we have linked there in those resources is access to the codes themselves. The IECC, the Illinois amendments to the IECC, and the Chicago Energy Conservation Code. Be aware that there are over 60 pages of errata for the first printing of the 2021 IECC. So be sure to download that errata for the version you're looking at. Hopefully they'll be incorporated in the second printing, and that will be available soon. It looks like that second printing is actually up on the website, looking at the web link there. So some of that errata is being incorporated already. Something else we have available is our Building Energy Education Fundamentals courses. This is a new offering that we've been coordinating through the Department of Energy to provide some of this training. It's targeted towards community college training programs, but we are happy to provide it to anyone. They are free to access modules, a little more detailed than our Thinkific modules through the Energy Codes page. But again, targeted towards kind of a basic understanding of building energy fundamentals, getting people introduced to thinking about energy efficiency and building design. So please do make use of those resources as you're trying to become more familiar with the energy codes and more familiar with building efficiency in general. So today we are covering air leakage and blower door testing. Coming up, we have two workshops where we're comparing the 2019 ASHRAE 90.1 requirements with the 2018 IECC. Kind of gives you a blend of looking at the differences between the IECC and ASHRAE as far as formatting and navigating the code, and also a bit of a preview into what's coming with the 2021 IECC. At the end of May, we will also be digging in depth into those 2021 IECC updates before that's released by CDB. At the end of June is the anticipated implementation date for the 2021 IECC as the Illinois Energy Conservation Code. And then we do have in June our last webinar touching on testing and verification. That's looking at how to actually make sure that the code is being properly implemented at your facilities. So let's dig into our blower door testing procedures. So what is building pressure testing in commercial and residential? In general, the procedures for these are the same. You're going to take a building, seal up any openings to the outside, such as windows, doors, engineered ventilation openings should be sealed up. You want to test the tightness of the envelope, not necessarily whether dampers and things like that are working correctly. That's separate testing that gets done as part of the mechanical contracting. So those kinds of openings will be sealed up in the building. You'll place a fan in a doorway. It could be one of these residential style fan units. For larger buildings, they do have multi-fan units that can fit in doorways as pictured on the left there. Or it could be a larger commercial type system. We've seen truck mounted units that are also available. And those will depressurize the building, the pressure reading, the flow reading that you get, that you know how leaky your building is in general. And that gets compared to energy code requirements. So why would we want to do blower door testing? Again, it's going to determine how leaky or tight your building is. It's an excellent diagnostic tool used to find points of air leakage, diagnose building pressure problems, can even help evaluate moisture problems like condensation and mold by finding where those air leakage pathways are in your structure. It also quantifies reduction of air leakage for weatherization work or specific air sealing work, so that you know how well the crew did in their air sealing efforts. And for crews doing air sealing, it helps to test their work while on site, particularly for new construction, making sure that those air barriers are correct and installed to specifications. So on the residential side, in the 2018 Illinois Conservation Code, pressure testing is at 50 pascals for residential buildings, and the leakage rate is based on volume of the building. It's important to note there. So it's going to be based with Illinois amendments on 4 air changes per hour. For multifamily buildings, there is an Illinois amendment that adjusts that to a quarter CFM per square foot of envelope area. But in general, for single family homes or standalone structures, that 4 air changes per hour is the requirement. Again, you want to ensure that the envelope is sealed, including purposeful openings like fresh air vents, closed doors and operable windows, and then pressurize or depressurize the envelope. You convert that CFM reading that you get from the fan into the reading required, which would be air changes per hour for the standard test, or that CFM per square foot of envelope for the multifamily test. In the 2021, some updates are coming to those requirements. They do add backstop air leakage requirements for alternative compliance paths like the performance path or the ERI compliance path. That air leakage can now no longer be can be no more than 5 air changes per hour when following that volumetric procedure, or 0.28 CFM per square foot of enclosure area for the multifamily test. And again, that pressure is at 50 pascals for the residential side. The exception is for heated private garages. If they are thermally isolated from the building, those private garages can be visually inspected for air barrier integrity and do not need to be tested. The IECC also incorporates a 0.3 CFM per square foot at 50 Pascal multifamily dwelling test, which is slightly different from the Illinois amendment in the 2018 IECC. So it's a little bit less stringent than what we currently have per the Illinois amendments, but it will be now standard in the IECC to have that 0.3 CFM per square foot of envelope area for multifamily dwelling unit testing. And this backstop is to help ensure that when you're doing trade-offs in the envelope, you're not going to create a condition where you have ultimately a poor performing building, even though you've met the minimum energy code requirements from modeling. So they're just trying to make sure that you're not trading off air tightness of the building through other things like improved windows and insulation or improved HVAC equipment, because overall that will net a poor performing building. Air tightness is a key component of making sure those systems work properly over time. So for the multifamily housing testing, again, in the 2018 IECC, it's an Illinois amendment. It's not currently built into the IECC, so Illinois added the amendment that you could do testing for multifamily based on square footage of the envelope at that 0.25 CFM per square foot at 50 pascals. It's also includes a sampling methodology that allows for buildings that have more than 7 units to do a sampling procedure, so that you don't have to test every single unit in the building. Something important to note there is that for each unit that fails, you have to test an additional 2 units. So if you have a unit that doesn't meet those air leakage requirements, you will have to test additional units after corrective actions are taken to ensure that all units in general are going to meet that air leakage requirement. In the 2021 IECC, again, just noting, it's going to be 0.3 CFM per square foot is the base compliance path for the IECC. It has a very similar sampling methodology built into it. So in that regard, it won't change, but it is important to note that there is that slight testing difference. It's a little more lenient in the coming 2021 IECC than the current Illinois amendment is. The test is specified as an unguarded blower door test. So what we want to cover next is what's the difference between a guarded blower door test and an unguarded test, and why is that unguarded requirement in there. So a guarded test is a compartmentalized test of individual units. So you either pressurize the entire building and get a leakage rate that way, or you isolate a specific unit so that air can't leak between neighboring units, and you test the air leakage through the envelope of that specific unit. And specifically, you're only measuring that air leakage through the envelope to the outdoors. In the unguarded test, though, you're allowing leakage to occur between the neighboring units when you're testing that unit. So you're testing the entire envelope of that particular unit, including the interior partitions. So something to be aware of there, that unguarded test is simpler to do. So when you're doing a large number of tests, you're not having to do more air sealing work, more isolation work around the unit. And that's why it's the preferred testing. But it does include air leakage between neighboring units. So it's important to be aware of that when you're concluding, looking at the results of that test. One of the side benefits of requiring an unguarded test is that multifamily buildings and even in commercial structures, it allows builders to also check if fire stopping is properly installed, as these materials are also closely aligned with the proper air barrier alignment. So if you've got a large opening in a partition, that's also a fire penetration that needs to be addressed. And that brings us to our first poll. Go ahead and launch that. So our first question is, what is the present Illinois maximum air leakage limit for residential building envelopes? 5 air changes per hour, 4, 3, or 2? And then for the residential testing procedure, what is the test pressure? Is it 0, 25 pascals, 50 pascals, or 75 pascals? And we did have a question come in. Have we ever seen this done in a hospital situation, such as isolation or operating rooms? And is there a requirement for leakage in that situation? I'm not aware of the specific requirements there. I expect that in the healthcare setting, there are different requirements than what's in the energy code. And I would have to see what the health and life safety codes state for isolation rooms. I'm not sure. Ryan, do you have any idea there?
Yeah, there's nothing in the energy code, kind of as you allude to. This may be a safety code or healthcare specification may require this. Uh, However, this is an excellent way to test and verify that isolation or operating rooms, rooms that should be isolated from one another. This is a great way to test and verify that those actually are properly isolated from one another. And we'll talk a fair bit as far as some of the difficulties of doing some of these tests when you get into commercial, and in particular when you're trying to deal with isolation or just very specific targeted testing. Yep. Lost your audio, Sean.
Sorry about that. For our first question, looks like most people got the answer correct there. It is 4 air changes per hour in Illinois per our amendments. For the 2021, it will be going to the IECC's 3 air change per hour. So that will be decreasing in the future. And for our second one, looks like most people got that correct as well. The residential test pressure is 50 pascals. All right, I believe we will turn it over to Ryan to cover the commercial side.
All right. Also have a couple of good questions here, and we'll touch on some more of this. But understanding volume versus square footage. Anytime that we are talking about square footage, we are including the envelope area, the square footage of the envelope area, not necessarily the floor area square footage. So being aware of that, this is the outside of the box area. So understanding and making sure that you are aware of that. Someone else raising the note as far as leaky and loose construction. That is something that we had seen on particularly the residential side over the last several years, dramatically improving once testing was required. And this is something that's coming to the 2021 IECC, is testing in commercial buildings. So a little bit about how some of these tests are done and how this varies from residential is, we do use a higher test pressure of 75 pascals rather than the 50 found in residential. Part of the reason for that is commercial buildings generally are larger buildings and may have other more dramatic impacts such as stack effect placed upon them. And so using a higher test pressure helps leaks in the air barrier stand out a little more. Also for commercial, this is kind of similar to the multifamily residential, is again, we're looking at the envelope area, and understanding that, yes, we're looking at all the outsides of the box and adding up all those areas. So what is the exposed envelope area to determine that? And For commercial buildings, understanding again, because they are fairly large, there is some methods that allow you to sample areas of the building rather than trying to test an entire building at one time. Uh, under because testing a large building, if you have a 200, 300,000 square foot, or even some of these, million square foot buildings, trying to do that as a single test can be very difficult to achieve. Also with commercial, here we see a zero 0.4 CFM per square foot. So it's a little bit higher than the 0.3 or 0.25 CFM that we see in residential. Part of the reason for this difference is, again, this higher test pressure. So as you raise the pressure, you're going to have a higher volume going through that a particular area leakage point. So we're going to be testing a higher pressure, understanding the surface area of a building, and then doing targeted testing if we need to for larger buildings. And as I kind of alluded to earlier, testing and verification coming in 2021, IECC, which at the present time is slated to be implemented here in the state of Illinois for permits beginning June 1st. So that's coming up pretty quick here. But testing and verification is going to be required for commercial buildings. There are certain exceptions listed in the 2021 IECC, or International Energy Conservation Code. However, climate zones 4A and 5A, which is where Illinois is, are not listed anywhere in those exceptions. So what this means is commercial, for new construction commercial buildings, energy or air barrier testing is going to be required. Previously, there was a materials list that was more common for this, and we are going to, I predict that we're going to see a very similar learning curve in the commercial side that was seen in the residential side about 10 years ago when testing became required. All of a sudden, people understood and started to identify where a lot of these common leakage locations were, and where we thought the air barrier was continuous, identifying places where it was not continuous. Now, as part of this, the testing is going to split into two different testing methodologies. Part of this is going to go back to, are you testing more residential style of building or a more commercial style of building? Understanding that the commercial provisions of the energy code do include multifamily residential buildings. So you could have a commercial, testing required via the commercial provisions, but you are testing a more residential occupancy. So here noting, dwelling units for Group R residential and Group I institutional are going to be tested using a different methodology or a slightly different testing parameters than all other commercial building types. So with that, kind of looking at what the differences are. So for Group I and R dwelling units, we're going to use very similar to the residential style. We're going to do unguarded pressure testing at 50 pascals. And again, using that 0.3 CFM per square foot of enclosure area. Again, looking at this and saying it's very, very similar, and they're trying to mirror the residential small individual dwelling unit testing with the commercial buildings that may include residential units in them. And also, as Sean mentioned earlier, if you do have more than 7 units, you can use a sampling protocol. You do have to have at least 7 units that you do test. So if you do have larger than buildings greater than 7 units, then a 20% sample rate is required. If any of those 20% that is tested fail, then additional testing is required of more units in order to verify the proper air tightness is achieved. So uh, really for this, what it kind of boils down to is you have to test at least 7 units you have to test 7 units until you get to a building that is at least 35 units. Then you'll have to begin to test more than 7 units. For all other commercial buildings, again, this is using that higher test pressure and a little bit higher leakage allowance for that. And again, there's areas that you can sample for that. So what that sampling looks like for commercial is all envelope area for stories that have spaces directly under roof. So here in our little graphic here, we see all the area in blue at the top of the building is directly under roof. So we're going to have to test that area. Next is stories with a building entrance or exposed floor, loading dock, or below grade. So here we have that colored in red. So we're going to have to test everywhere in blue, and we're going to have to test everywhere in red. And then once we've tested everything at the top of the building and the bottom of the building, now we get into the center of the building. And what this allows for is testing representative above grade sections totaling at least 25% of the wall area remaining. So here we're testing the area indicated in orange in the center. We're not going to necessarily test the area that's in white or the white windows, if you will. However, understanding in a case like this, I'm likely to test an entire floor rather than trying to test a portion of a floor because that's going to be rather difficult in getting into understanding the limitations of your testing process and where is your air barrier. Because a partial floor probably is not going to have an air barrier appropriately or of an appropriate integrity in order to actually do your testing. So again, this is showing kind of the minimum testing that you would have to do, testing the blue, red, and orange areas. So next, understanding who needs to do this test and what verification there is. So for typically, these are done by third-party contractors that do specialize in this. For commercial, we're going to see people who specialize in commercial buildings, understanding that the equipment required, while the equipment such as the fans may be the same between commercial and residential testing, commercial buildings typically require more equipment, more fans, and perhaps some of the more specialized multi-fan panel units in order to actually carry out the testing. Something to be aware of is the authority having jurisdiction does need to approve your testing agency. Again, wanting to show that and demonstrate that yes, these are third parties who have an understanding of what commercial testing requires. On the residential side, again, typically this is through a party approved by the building official or the authority having jurisdiction. We do see in residential, sometimes these are done by the builders or contractors. However, in the event that a builder or a contractor does this, we do see a common request that the code official says, I want to be present for the test just to verify that the protocols were followed, including proper air sealing, but not excessive air sealing of joints. We do see a lot of this being done through HERS raters or other certified third-party contractors for residential, but there is nothing that prohibits a contractor from doing it or a builder or other construction personnel from carrying out the test, as long as that is acceptable to your code official for that. So with that, let's touch on another poll here. Check and see if we've kind of covered what we were looking to cover for that. So the first question is, what is the present Illinois air leakage limit for the building envelope? 0.4 CFM, 0.6, or 0.8 CFM per square foot for commercial buildings? And then for commercial buildings, what is the testing pressure? 0 pascals, 25, 50, or 75? So did have a question come in regarding the roof. If the envelope area includes the roof surface area, again, this will be based on what is the where is your air barrier defined. So for commercial roofs, where the air barrier is the ceiling and you have a pitched roof, then the roof area would not be included. If the air barrier is the roof deck, then the roof area would be included for that.
Looks like we've got most of our poll responses in.
Okay, so did pick up, yes, 0.4 CFM per square foot is the air leakage limit. And the testing pressure, again, for commercial is 75. So yes, excellent. People did pick up on those. So with that, let's talk about actually preparing to do the testing and then the actual performance of the testing itself. So first, we want to make sure that the envelope is prepared to do a test. Again, understanding where is our air barrier and is our air barrier as intact as we intend it to be. So, have we made sure to seal everything? That's all our penetrations, ceilings, walls, plumbing penetrations, HVAC line sets, ductwork penetrations, any penetrations through that air barrier, have they already been made? And the seal reinstated. So have we made the hole, run our HVAC line set through that hole, and then sealed around that line set to restore the integrity of that air barrier? So that's our first check, is do we have an appropriate air barrier to test? So testing can be done a couple of different ways. You can do a single point test where you just bring the building to the test pressure and run your test. So this is a single point at your registered test pressure. This single point test, however, is much less accurate than a multi-point test. What this will do is with multi-point tests, it runs the testing through a range of various pressures. And depending on which testing protocol you are using, whether you're using the IECC testing protocol, which is also along with the ResNet standard, or the Army Corps of Engineers testing standard, which does things a little bit differently as well, and is also a more rigorous testing standard than commonly used. However, being aware that that is out there, and so for those of your clients who may be interested in a more thorough and rigorous testing, you might look at and consider encouraging them to use that standard. And so, as we're noting here, the multi-point test will take a series of readings at 5 or more different test pressures. And again, because we're testing at different pressures and testing at different points, that generally is a little bit more of an accurate test. Because of this, the single point test in the code is penalized by about 10% as far as trying to account for some of that inaccuracy. Fortunately, with today's technology, carrying out a multi-point test is requires very little in the way of extra effort. All you're doing is telling the program to do a multi-point test rather than a single point test. It does take the program a little bit longer to run the test, but because a lot of this testing has now become automated, it's not terribly difficult to carry out the multi-point testing. Something to be aware of is, and I believe the Army Corps standard is, not only do they require a multi-point test, but they require that the testing to be done both pressurized and depressurized. So you'll run one set of tests, turn the fans around, and then run a second set of tests. Part of the reason for this is because of, as Sean mentioned earlier, damper leakage. Dampers can leak differently depending on if the building is pressurized or depressurized. And so again, this is where that test is trying to really focus in and make sure that we did get a good seal all the way around and make sure that that is intact both directions. So blower door testing does not have to be a once and done thing. One can use blower door tests throughout construction. The first, you could potentially do a test run as soon as your envelope is complete. Once you've got your framing up and your windows in, before you've made any other penetrations, as soon as your envelope is complete, you can perform a blower door test just to see how good was my envelope before I impaired it at all, and starting to understand, because I'm going to make penetrations, I'm going to make this worse. Understanding before you've made any penetrations, how close to that mark are you going to be? If you go through and you build your envelope and before you have any penetrations, you're already at a 0.4 CFM per square foot, you will be in trouble later because once you've made penetrations, we're never able to quite get a perfect seal afterwards. So if it starts at 0.4 and you're already at your limit, you're going to want to make some improvements before you start going further. So obviously we do need windows and doors in place in order to have an envelope that even could be tested. Some plastic sheeting over nailed on is not going to bear that testing pressure well enough for you. So as far as how to operate do the test, making sure that we've got all the windows and doors closed and latched. You can't seal windows and doors beyond that level of closure. Now dampers, so here noting we're going to seal or close and latch, doors, windows, dampers for standard equipment. And these are not to be sealed beyond your weather stripping. Now, when you have continuous ventilation systems, commonly for commercial buildings, these are going to be a lot of times through rooftop units and the like. So any ventilation system, you seal those penetrations. So we want to close dampers, but we're trying to seal the penetration because again, the duct that's running through that, we want to seal that because that's not really what we're trying to test. We're trying to test the envelope that's around that ductwork. This is where it gets really challenging as we're moving into commercial building testing. This is something to think about, is how are you going to provide these seals for the continuous ventilation systems? Contractors will commonly use tarps and tape and other methods to perform the sealing, but as design professionals and code officials, we can help support the development of this just by asking a question in advance and saying, okay, how are we going to operate this test? you might go ahead and reach out to a testing contractor as part of your design phase and say, okay, for a contractor who does this, here's what I'm thinking. Is that going to work? Is it not going to work? What can I do as part of the design to make this easier? One area that we do see this is for roof relief openings, is making sure that that cover is able to be removed. A tarp or other piece of material can be fitted across it, and then the cap can be reinstalled over it, so that way it holds that material in place, and also the cap doesn't go flying during the testing. So also, before running the test, we're going to want to make sure that all our HVAC is turned off, so all the fans are not running during this testing, and then making sure supply and returns are open so that air can pass around that building. Because again, the fans are going to be located generally in one or two areas, and we need to make sure that that airflow from the fans can be distributed throughout the whole building. For new construction, we often see plumbing traps, making sure that we have sealed those up properly. Make sure you go around and fill, put water in all the plumbing traps. This is something where you'll generally find it pretty quick through a sewer odor that starts permeating your building really quick. You'll find that plumbing trap in a hurry, and generally that's where you might look if you're having a difficult time achieving your test pressure. Is, did I miss one of the plumbing traps, and so I'm pulling air through the plumbing system. So something else to be aware of as we're moving again into commercial testing is understanding how many fans are we going to need. So this is a given fan, one building pressure testing fan, such as those shown here. For the residential side, also group R or I, they can test about 18,000 square feet of envelope area per fan. The commercial, so all other commercial buildings, because we're testing at a higher pressure, we can't test as many square feet per fan. It can only do about 12,000 square feet of envelope per fan. So that's a good kind of thing to keep in the back of your mind as far as when you're beginning this process, is starting to say, okay, how much equipment is likely going to be required to carry out this testing, and understanding that because we are looking at envelope square footage and not floor plan or footprint square footage, you can have some fairly large buildings that have relatively low envelope square footage. We have seen buildings, 180,000 or actually over 200,000 square foot of floor area. However, their envelope area is much lower than that, so they might be able to be tested with about 7 or 8 fans, even though based on their floor area, you would think they would require much more than that. So with that, let's touch on let's get another poll question here. So first, looking at how many blower door tests can one conduct on a building? None. 1 test, 5 tests, or there is no limit to how many tests you are. And number 2, when is the earliest testing can occur? This should be for code compliance. Sorry, I do apologize for that. So when after the exterior walls are framed, once the air barrier is completed, once the air barrier is completed and necessary penetrations are made and sealed, or just before final inspection. So when is the earliest testing that is allowed for code compliance? You may test before or after for other reasons.
Don't see any questions that popped up in the chat or the Q&A. Oh, we just got one in the Q&A. Does a warehouse need to comply?
Warehouses with conditioned space will need to comply with this. So that's one that that's a big that's definitely going to be a big concern out there. Fortunately, with warehouses, your leakage points are going to be probably fairly obvious because a lot of warehouses are tilt-up precast concrete. So with sealed joints between it, so your leakage points are probably not going to be in the walls themselves, but they're probably going to be, at your loading dock doors. And did you specify loading dock doors with good air sealing, uh, roof to wall uh, intersections? That's going to be a real leakage point for warehouses. So again, this is going to be for new construction that this is going to be required. So existing renovations and alterations will not require blower door testing. However, might be a good idea, again, because air infiltration oftentimes brings comfort in indoor air quality issues because heat and moisture come through with the air. So as far as blower door tests, that is correct. There is no limit to how many blower door tests you can conduct on a building. The earliest a testing can occur for code compliance is the air barrier must be completed and the necessary penetrations need to be made and sealed. So most everyone got those correct. This is one area that we do see common difficulties, particularly for the residential, because that's where testing has been required for some time, is too often we see blower door testing saved until the very end, just before final inspection. Unfortunately with that, because everything has been covered up, in the event that you are unsuccessful at passing your blower door test, that makes remedies much more difficult to find and make. So that is one of the biggest challenges that we have seen, is doing it too late. Do it early, as early as you can. For something else that is available, I don't think we're going to touch on it too much here, but I will mention that there is ultrasonic building envelope testing that can be performed. This would not be for code compliance. However, it's a technology that is available. So if you do have a larger building and you want to make sure that you get that you want to definitely help make sure that you're going to pass your blower door testing, you could do some preliminary ultrasonic testing to identify leaks and remedy those ahead of time before you get to final testing. And part of that is, again, because commercial testing, in order to shut down the HVAC systems completely for the testing and making sure that you're sealing up all the dampers, commercial blower door testing can take a fair bit of time and can be difficult to manage around trades because you need to be able to maintain the integrity of the envelope during the testing. So you can't have contractors going in and out of the building during the test. So we will touch a little bit on alternatives. Part of this is because this is presently available in the code. So for commercial buildings, you can either do testing or you can do this through materials and assemblies. There's a list in the code book of, I believe, 11 different materials and assemblies that are listed as qualifying as air barriers. And so this is how air barrier testing has been done in the past. It's just saying, well, I used one of the materials, so I'm good to go. Unfortunately, just using the right materials does not necessarily mean they were installed properly. And this is likely what we're going to find as we transition into requiring commercial testing is, the materials and assemblies, the installation methods are definitely going to need to improve over time, which this is even why the Army Corps and GSA for the federal government has required this on all of their new projects, is because when they previously had relied on materials and assemblies, when they later came back and said, well, let's just test to see how well that worked, they were finding a lot of problems with it. So they said, we're just going to test it all the time. So as part of this, first thing is making sure you go through your plan inspection and identifying where all the air barrier is supposed to be and making sure, did I get enough details to that, and coordinating between trades. You know, I can have different trades between my framing and my concrete work and my fenestration that all kind of comes together, and the metal workers, you know, understanding, okay, who is going to seal this and in what order, because you want to make sure that you don't have someone comes in, okay, I got this put in, I've sealed it, and another trade comes along and makes a hole in that seal. So understanding, okay, who is going to do this and in what order that is. So, and again, checking where are my hot points, you know, around flues, any duct work, making sure what am I sealing. So doing that at plan inspection. And again, this would generally be done by, if you were doing this for code compliance outside of the state of Illinois in the future, this would be done by a third party commissioning agent. So they're commissioning this envelope, checking the plan, making sure that it is adequate and that is constructible, and then following with site verifications. So following up multiple times throughout the process and checking all the various air sealing detailing. Did it get installed? Did it get installed correctly? Has it been impaired since installation? And the like. You know, so they're going to look at the air barrier as it's exposed and then as it's covered up. So trying to avoid, you know, bridging between materials. Anytime we see a bump out, that's really going to cause a lot of challenges anytime you have these corners. You know, here we're showing bridging and fish mouths where two materials overlapped, but they weren't quite the same. So again, this is going to require a lot of coordination. So first, making sure that can we even do we have a continuous air barrier that could be constructible? Then did it actually get constructed per the documents? So with that, again, we're not going to dive into this too far, because while this is presently available with the adoption of the 2021 IECC, this will no longer be allowed for new construction. This will only be allowed for existing construction. So that, again, this would be very good as far as identifying, have I done my construction review during plans, and then have I inspected it appropriately during construction. So that we'll hold a couple of minutes, few seconds here to see if there's any other questions that might come in. But if you do have any questions after today's session, feel free to reach out to us. Again, energycode@illinois.edu. And again, today's session has been recorded and will be published along with a PDF of the slides to our website. And everyone today will get a certificate of participation. If you do need AIA or ICC credits, there will be a link in that email to you that you can follow to provide your AIA or ICC information, so we can go ahead and get that reported. Questions regarding testing of additions to homes and commercial buildings. Testing will not be required for additions and alterations to existing buildings. Testing will only be required for new construction.
We did have a question come in about kind of the length of time it takes to do the test. For residential homes, I used to do that testing, and it would take about 30 to 45 minutes to set up the test, walking through the house, making sure things are properly sealed, windows are locked, that kind of thing. Depends on the size of the house too. A larger home would take a little bit more time. But figure around a 2,000 square foot house takes about 45 minutes to set the test up. To actually run the test, the single point takes uh, 30 seconds to a minute to run that test. If you're doing the multi-point, it's a couple of minutes to actually run the test. And then to tear everything back down, remove the ceiling that you did, things like that. So grand total, you're probably looking at somewhere around an hour for most residential homes. Um, for commercial buildings, it's going to be a lot more because there's a lot more penetrations. You've got a lot more ventilation openings for the HVAC systems. Um, and you're going to have to find ways to seal them in kind of ingenious ways, as you've got rain hoods on these things and things like that. We're going to have to work out tarping and taping, or some other sealing method for those materials. Commercial will take significantly longer. It's going to be highly dependent on the size of the building, and how long it takes to get to these different points that need to be sealed up. Um, so commercial, it's hard to estimate without knowing like a size of the building or something like that. But it's more than likely going to be a couple to a few hours to do the testing for that.
Yeah, the actual test itself is definitely fairly quick. Commercial will take a little bit longer, partially because you're dealing with much more volume. So it just takes a while longer to actually come up to the test pressure in order for the fans to move enough air for that. But yeah, I mean, residential, the actual test, yeah, a few minutes. For commercial, again, that's going to range depending on the size of the building, how long it takes to come up to pressure. It would not be uncommon for a commercial test on a large building to take upwards of a half hour, just to bring the whole building up to pressure and so forth. So
Did
yeah,
have a
it's all the
question.
prep work that takes a long time.
Yeah. We did have a question on this slide here. What's the bridging? When you've got a bump out in your structure here, there's this slight bump out. And this is an adhered air barrier. Instead of following the contour of that bump out and making a couple of 90-degree bends, they've stretched it too far and left an air pocket there. So that air pocket is what they're referring to with the bridging. And the fish mouthing is where that air pocket doesn't seal between the different sheets because there's not a hard surface behind it to seal to. And so it then leaves an open gap in the air barrier there. So that's the bridging it's talking about. There's overstretching that insulation where it doesn't, or that wrap where it doesn't follow the actual contour of the building.
Question as far as for commercial buildings, if the commissioning, if the envelope commissioning has to be done by a certified building envelope commissioning agent, there's nothing in the code that requires that to be done by a certified commissioning agent. It is again up to the what is acceptable to the code official. Do they have an appropriate understanding? And part of that also goes back to testing a small bank building is going to be very different than testing a large office building. The skills required for a small town bank might be much more akin to a residential home because the construction is going to be very similar of that.
We had a question here about do you need to test an existing commercial building with changes in occupancy to a residential type structure? So changes in occupancy usually require full compliance when they are going to increase the energy consumption of the building. So it gets a little tricky here in trying to figure out, is this change in occupancy going to increase the energy consumption of the building, which would then trigger full compliance.
Yeah, when you go from commercial to residential, that's also a trigger for full compliance. This is one we would definitely have to read the specific language to that, um, I think probably what you would end up with is it's probably going to be impractical to uh, do that. Uh, oh, now, where that it might be something where they look at it and say, you do need to do the testing, but how are we going to manage if you're not at zero 0.4 CFM per square foot? What are you going to do about it? That's going to be part of the just practically speaking, you may run into challengings. So it's that's something I will have to dive further into on that question to know exactly what would or would not be required. Uh, so uh, jurisdictions to require testing for existing homes so prospective owners know the results. I have not seen that. Where that might have come into play is there are jurisdictions out there, I don't know if they're in the state of Illinois or not, that require a HERS rating to be done upon sale or transfer. So, which I imagine a HERS rating would, part of that would be doing a blower door testing, but I don't know if there's any jurisdictions that have specifically required the testing itself.
I'm not aware of anyone specifically that requires that testing for existing buildings. Somewhere else that we have seen that though is for energy efficiency mortgages, um, where the better performing the home is, the better rates they get on their mortgage rates, particularly if they're planning renovations to a home. So we've seen that in that instance as well, but usually not just a requirement for sale. Okay,
And
I think
there
that's
again,
all the questions that have come in.
uh, that's where some of this is going to be as people become more accustomed to understanding that if we build a building tight, that gives us the ability to or better control over the environment, which may be desirable. So as this becomes more commonplace, we may see more people do it and say, oh my gosh, yeah, let me try to make improvements to my house. So.
All right, well, I think we'll wrap it up there. Thank you all for joining us this afternoon. We hope you found the session informative. Again, if you do have any questions, please follow up with us at energycode@illinois.edu. And thank you all. Have a wonderful afternoon.